So today we'll be starting with the stairs. Okay. So if I share my screen now, we'll take a question here on stairs. Stairs, I know you all know about what the types of stairs, etc. Tread, riser, I hope you all know. So we are just going to design a and since we have the chapter buildings, so on buildings, flat slabs we have done, and then we are going to uh, take a question on stairs also. So if I share my is this screen visible? Okay. Okay. So I know you people know what are stair treads, risers on a staircase. Right. If I take this notation here. Okay. So we all know that in residential buildings, you all know in the stairs what are treads, risers. Yes or no? These things like if I take this red color. Yeah. So your steps in this way are your steps. You all know this is your right. This are your risers. This vertical portion is your risers. This vertical portions are your risers. This horizontal portions are your treads. I know you people know these things, and this is your waist slab. This is your waist slab for the stairs. Okay, since you will have in this way your steps from here like this. So so for the generally for residential buildings, these treads and risers, they are hello. Okay. So what I was telling, yeah. So now for residential buildings, these things you must know for residential buildings. For residential buildings, how much we take our riser we take it to be between 150 mm to 200 mm. Okay, and our threads we take it to be between 200 to 300, sorry, 300 mm. Okay, so this was our general this thing for residential buildings. These are the ranges for risers. We can assume when you are designing, you can assume it to be between 150 to 200, or the for treads 200 to 300 mm. Okay, and also between these range, generally these are your riser and thread dimension. These things sizes you take for the riser and thread. But in public buildings, sometimes you may take generally for public buildings. If we see for public buildings, what we do generally for public buildings, generally we take our riser to be 150 mm, riser to be 150, okay, I'll talk here. Tread to be 270 mm. Okay, then for such as factories or where there are lots of heavy works and where you have to carry different huge machines or any kind of heavy loads or structure where there are busy schedules and works are going on like factories etc. There we consider our riser to be generally we take it to be 190 mm, and for threads we take it to be 250 mm. Okay, and for like cinema, for public places like cinema halls you can say, or theaters etc. So there what you can take your riser to be 150 mm. Okay, and your thread to be 270 mm. Okay, so this are general things like for this thing 150 to 200 is your riser always whenever you are designing it should be in this way. Thread 200 to 300 for public buildings you can take it to be this much etc. In some heavy where there are more crowded places etc. there you can take your these things to be more your thread maximum because this is your thread the vertical sorry the horizontal portion, so this threads you can make it little bit more so you can take it the maximum value 300 mm up to 300 mm maybe because you want in an overcrowded place you want it to be more such that there is no not much to just reduce the to some amount the make it comfortable for the crowds. Okay, so if we take this question here now, okay, one some more things I want to tell you, like if I write here the width of slots stair sorry 100, it is generally between 100 yes that means 1100 mm to where is this to 1600 mm. Okay, the width of the stairs means like suppose these are your stairs if you see from the top view. In this way you're going to see from the top view your steps, right? So these are your width of the this thing stairs, this one, these are called your width, this is your tread, this is your riser, this is your waist slab. Okay, and also what is your waist slab, the thickness of waist slab we take it to be between 1 by 28, where is 1 by 28 to 1 by 25 times the okay period of 5 minutes of the span. Okay, so what are your this thing width of the stairs? We take it to be 1100 to 1600. Whenever you are designing, you can take between these two. Thickness of the waist slab. This one is your waist slab. So what can be the thickness of the waist slab? That is taken to be 1 by 28 times the span or 1 by 25. Between these values, we can take any values for thickness of the waist slab. We can take that. Okay, so these were the general things which you should keep in mind while designing the stairs. So if we take this question now here, if we take this question, design a dog-legged staircase for an office building in a room measuring this 3 mm. If we assume this, not assume, but we have a building here. Sorry, the room building is how much? The staircase room 3 meter into 6 meter, and the floor height is how much? 3.5 meter here. Yeah, 3 into 6, floor height is 3.5. The building is a public building which is liable to overcrowding. See here, it is overcrowding. So with the help of this, we can assume our this thing risers and treads. Then we have a staircase are supported at brick walls 230 mm. These staircases are supported at brick walls at 230 mm thick at the end of landing use, okay, thick at the end of landings. Now also use M20 concrete and Fe415 grade of steel. One more thing is to be added here in this question. What we can add, yeah, it is not mentioned here, but we'll take it. Consider the ceiling finish to be 12.5 mm. Okay. Consider the, okay, you can add this to your, question here. Consider the ceiling finish to be 12.5 meter. It was missed out there. Okay, so now if we try to solve this question, that means we want to design this dog-legged staircase. So here we will be assuming our these things, tread, risers, and then we are going to design that. So let us start designing here. So we are given what? The size of the room, we know. This one, the size of the room is given, the this thing floor height is given to us. FCK is known to us since it is M20, so FCK is 20, FY is 415 here. Then we have the, here we will take it to be how much, we will assume our riser to be 150 and the tread to be 300 mm, because I told you that for public building, since this is a public building, we can take our riser, generally we take our riser to be 150, tread we take it to be 270, but here since it is overcrowded, so what we do, since this is overcrowded, so the maximum value for the public buildings, it was how much? For tread it was 270, 270. So but we are taking it to be 300. Generally the range which we could have taken for tread in buildings is was what, how much? 200 to 300. So we take the maximum value since it is overcrowded and we want it to be more our tread, such that for free flow, or you can say the comfortable flow of the crowded crowds. Then height of the flight will be how much? Now height of the flights, we know our this thing was given to us, floor height. If the floor height is 3.5 meters, so we have our steps in this way. uh, your steps will be like this, right? This one, from here, then from here, this is your steps. So this is your height. So the height of each flight will be how much? This flight will be how much? Since this is 3.5, we know. So 3.5 divided by 2 if you do. So you will get your, this thing, height of one flight 1.75 meter, you see here. So once we get that single flight height, once we get this flight, once we get this height, okay, so number of risers we can find out. This one, number of risers, this one, the vertical one, number of risers will be how much? This, if this is this much, that divided by our number of risers, this riser, the riser was how much? 150 mm. So we know that our riser will be height, since the number of risers will be how much? The total height of the flight, divide, if we divide it by this riser, we will get how many number of risers it should be there. So we got our riser to be 11.6, okay, which is not possible for 11 and a half steps. So we take it to be 12 numbers, and generally we restrict, you should remember this, that the riser, number of risers is always restricted to, generally restricted to 12 numbers, okay. So and then tread is how much? Tread is always one less than the riser. If your riser is 1, 2, 3, 4. Your tread, you see here, 1, 2, 3. Okay, that means your tread is always less than 1 less than your riser. So if your riser, once we have calculated our riser, we know what is our tread, 11 numbers, 12 number of risers, 11 number of treads. So the total length of the tread will be how much now? Since we know these treads, the horizontal treads are how much? 11 numbers. So 11 into our tread was how much? This one, 300 mm. So if we do, we can easily get our length of the thread. Okay, this total length of the thread, we can find out this, how much is the total length of the thread, right? So now we can also find out the width of the landing. Once we know our this thing, 3.30, our this thing, where is this one, 3.30, the total length of the thread also we got. I'll show you here. If you see this figure, yeah, here, see this thing, this is the plan. If you see, these two are the flights. Okay, take them. Okay, so these two are the flights. Maybe it is entrance here. From here, this is the landing here, and then this one is the steps. Okay, so in the question it was mentioned that here is this room is resting on this brick wall, which is 0.23 meter, this one, and these are the landing. So once we know this room was how much, length of this was 6 meter. From here, this one, from here, from the landing to the steps to the this thing again, the landing, it is 6 meter, and this one was 3 meter. So once we know the length of the thread, these are your threads, right? The from the side view which you had seen, this, sorry, this. So these are nothing but this. Okay. So we have calculated just now the length of the thread. That means one thread was 300 mm we had taken, and there were 11 number of threads. So we can get this length, total length of the threads. So the thread length, total thread length is how much? 3.30. Just now we had calculated. Okay, so once we know this distance, 6 meter, from the total length we know of the room, 6 meter of the staircase room. So this is how much? 6 meter. 6, if we subtract by if we subtract from 6 this length of the threads, we will obviously get, we can obviously find out this two landing with this one, which comes out to be 1.35, 1.35. Okay, we got this. So now, with, see here also you can see width of the landings, 6 meter, this 6 meter minus 3.30 divided by 2, so we got this landing. Okay, 1.35, okay, meter. Now the effective span, once we know all these things, the length of the threads, this width of the, this one, the landing, we can calculate the effective, this thing, span. Okay, that will be how much? This one, this total is 6 meter, and this half of this and half of this is nothing but 6 plus 0.23. Half of this plus half of this will be nothing but 6 plus 0.23, so it is 6.23. The effective span of the flight is how much? 6.23. Okay, and this side also we can find out what was this. This was 3 meter. Okay, so this width of the landing, this width of the landing is equal to the width of the stairs. Okay, and also one more thing, if you see here, effective span of the flight we had calculated 6.23, this one. Thickness of the waist slab now. Okay, waist slab we used to take from 120 of span to 125, anything we can take. Okay, and this thing, remember, the width of the landing, this one, width of the landing is equal to the, this thing, your stairs. Okay, which is the width of the stairs. It is always equal. This width is equal to your width of the landing. Okay, so 1.35 we had calculated this width of the landing. So width of the stairs also 1.35, we have given 1.35. So from the 3 meter, when we subtract these two, we get the spacing here between the two flights. Okay, so this will give you your 0.3 meter. That means this free space between the two flights is 0.3 meter. Now, effective span of the flight we had calculated, this one here, 6.23 meter. Right. Now the thickness of the waist slab. Thickness of the waist slab, I told you in the beginning that it is between, you can assume it to be between 1 by 28 to 1 by 25th of the span. So if we take it to be 1 by 20, 1 by 20 into our, this total effective span of the flight was how much? 6.23 mm. So it gives us to be how much? Our thickness of the waist slab to be 0.3115. Okay. If I show you here. Okay. So this is how much this comes out to be, your 0.3115. Okay. So now, where is our waist slab? We are calculating the, okay, we are calculating this, the thickness of this waist slab. Okay, that means if this is your waist slab, this is your thickness of the waist slab here. So this is your tread and your riser is here. We know our tread was how much? 300 here, 300, and your riser was 150. So this thickness, how much we had got? We had got it to be 300. This one, 311.5. So we can, since we are designing, so we can take it to be a bit more also, no problem. Either 325 we can take it, or if you want 320 also you can take it. Okay, so that is depending upon you. So but we, after calculating the, we got the thickness of the waist will be minimum 0.3115 meter. Okay, 0.311, this is 1115 meter. So now after finding out the thickness of the waist slab, all those, the width of the landings, etc., so we got all the things. Now we can calculate our, coming to our load calculation, we can do our load calculation now. Okay, so here if you see, our dead load of the waist slab will be how much? The depth we have got it to be how much? 0.3115 into our 25, which is our, this thing, the unit weight of concrete RCC. So we got our dead load of the waist slab to be 7.7875 kilonewton meter square. Okay, so now again, there is, in the question it was given to us that we had a ceiling finish of how much? 0.10125 meter, right? So that was how much? This is our 0.0125. The ceiling finish is given to us in our question. So the into 24, because it is a plain concrete cement, so unit weight this much. So we got our dead load to be this much, 0.3 kilonewton per meter square. So now the total dead load will be how much? This plus this. So this is our total dead load from the waist slab plus the ceiling finish. This is our waist slab. We have here our tread, riser, tread, riser, tread, riser, tread, riser, tread, riser. Okay, so the life load is falling here on the tread. Okay, that life load, we know the dead load or the load on the stairs, or load on the stairs, consists of what? The dead weight of this waist slab here and the dead weight of this steps. Okay, fine. This load waist slab. First of all, we are calculating the waist slab thickness, that dead load from this waist slab, as well as the ceiling finish. flat ceiling finish, which also has a dead load. So this much dead load, total dead load from this waste slab. Okay, this waste slab, from this waste slab and the ceiling finish is this much. Now what we do, the dead weight per unit area is first calculated, this at right angles to this slope. Okay, the corresponding load per unit this horizontal area is then obtained by multiplying the dead load, which is our this. Now the total dead load from the waste slab and the ceiling finish is coming to be 8.0875, or 8, just calculate, you can calculate, I think. So this much, whichever we got the total dead load, that, because now we are, what we are doing is we are finding the load per unit horizontal area. Okay, and to calculate that, that is the this one, the corresponding load per meter of plan waste plus ceiling is how much, it is given by this. What I was telling you is that the corresponding load per unit horizontal area is obtained by multiplying this portion. This you have to know, which is root over r square plus t square by t, where your r, this one, is your riser, t is your tread. Okay, this is also t, which is your tread. Hence, our dead weight of the slab per unit of this horizontal area will be how much? This whole into this dead load, the waste plus ceiling. Okay, okay. So now what does this gives us? This comes out to be this much, 9042.09 Newton per meter square. Okay, so this we got the corresponding load which we are calculating per unit horizontal area we got. Now the total load actually which we are calculating now is that this corresponding load which we have calculated, that is going to come. Okay, and also the load I told you that the step load is also going to come, that step load. So that is given by this area of the step, that is half into base into altitude, this one. Okay, divided by your total tread. So that will give you your how much, this is the dead load of the step. Okay, so how much we got it, we got it to be 1875 Newton per mm square, that means 1.875, oh sorry, 1875 Newton per meter square, and in the bottom it is kilonewton per meter square. So actually what we are trying to find is the total load. Okay, so the total load is what, this total, that is this load of the step, from the step, this load from the corresponding, if I mark here, okay, this one, this corresponding load from the waste slab and the ceiling and horizontal per unit horizontal area, we have got to be this. The dead load we got it to be this 1875 Newton per meter square, this one. Now again one more thing is going to come, that is the dead load from the top finish, from the we had calculated the ceiling finish plus the waste slab dead load. Then also above the steps we had the steps, we had this tab. Above this also there is a finish, top finish. So that is also we can calculate, we can assume it to be 0.0125 mm, which was given to our meter, sorry, which was given to us in our question. Okay, or we can assume it. Okay, so we got it to be this, also we got it to be how much, 300 Newton per meter square. Okay, so now we the total load which is coming is what, this one, the load from the slab, the load that is the horizontal load per unit, sorry, the total waste slab plus the ceiling per unit horizontal area, then the top finish. Okay, bottom finish we have already included here. So these are the total loads, total dead load is this plus this plus this, you can see here, this one, the 9042.09, this one, 1875 the dead load of the step, and the 300, which is the dead load of the top finish from above the stairs. Okay, so this comes out to be your total dead load. So once we got our total dead load, we can calculate our what? Life load also. Then we can find out the factored load, this one. This one here. Life load is given to us in our question. Total dead load we had calculated here. Total dead load. So the life load is how much given to us in our question, 5000 Newton per meter square. Total dead, now the total load will be how much? The dead load plus life load, which was our, this was our dead load, and our life load is this much, 5000 Newton per meter square. So it comes out to be our total load to be this much Newton per meter square. So now what is our factored load, which is actually acting? Now the factored load, this was the total load acting. The factored load for safety is how much? 24325.64 Newton per meter square. Now once we know our load, we can calculate the moments, right? So we'll go to the next step, which is our moment calculation. We have calculated the dead loads. Now we can calculate the moment. Now, the next step, which is in your design of stairs, is how much? The calculation of the moment, which is W we have calculated just now. The factored load was 24325.5 Newton per meter square. Now, the bending moment per meter width of the stairs is how much? WL square by 8, which is W, you know, your factored load. Your L is the effective span, which is 6.23. That was, so this comes out to be, this is the total moment. Okay, so the maximum bending moment allowed for a single reinforced section is how much? This much, 0.138 FCK into BD square. So your maximum bending moment limit is given by 0.138 FCK into BD square. So FCK we already know, it is M20. B we know per unit, per meter length we are taking. So it is 1000 mm. Okay, so your D is how much? 325 they have taken. You can take it to be 320 or 3, and yeah, it was 311 point something we had calculated. So you can take it to be either greater than that, like 320, 325. Your, this is the waist slab thickness, okay, of the stairs. So this is your maximum bending moment, which is to be limited. So with the respect to this, we are going to calculate the reinforcement. Okay. Let me the attendance. Roll number one, enrollment one, sorry. Stephanie.
Yes, ma'am.
Okay. Uh, 4, 4, 5,
Yes,
6.
ma'am. Number five.
Number 5,
Yes,
6.
ma'am. Yes, ma'am.
Is present. 6. Ali is present. 7, 8,
Ma'am.
9,
Yes, ma'am.
8.
Yes, ma'am. Eight.
Good morning, madam. 9,
Hello, attendance is taken. You could listen again.
9,
Attendance is taken.
10,
10, ma'am. 10. 10 present.
No,
11,
no, no. It's okay.
12, 14, 15,
Good morning,
17,
ma'am.
Yes, ma'am.
14,
012.
1, 2,
Ma'am.
Ma'am, 14.
14, by 15, 17,
Yes,
18,
ma'am. 17.
18,
Yes, ma'am.
19,
18.
19,
18. Yes, ma'am.
19, 20, 21, 22, 23,
Unit 3, ma'am.
23.
Unit 3 present.
Yeah, 24, 25,
24 present.
20, okay, 26, 27,
Present, ma'am. 26.
27,
26
20,
present,
yeah,
ma'am.
30, 30, 31, 32, 32,
31.
32, ma'am.
31, 32, present. Then
32,
34,
32, ma'am.
Present means 34.
36,
Present, ma'am. 36.
37,
37 present
8,
ma'am.
38,
Present, ma'am.
39,
37 present ma'am.
okay, 39,
38, present, ma'am.
39, 42, 43, 45,
45
48,
present.
49,
48 present ma'am. 48
50,
48 present ma'am.
50,
present, ma'am.
okay, 50,
Be present, ma'am.
51,
51, present.
52, 54, 57,
57, present, ma'am.
60, okay, 60,
60. 60 present.
61, okay, 61,
Present means 061.
63,
Ma'am, 61 present.
63,
Present.
99,
Ma'am, 61 present.
yeah, 69 present, 101,
101.
104,
Present, ma'am. 104.
106, 8, 9,
108 present.
okay, 9,
109 present ma'am.
11,
Present, ma'am.
13,
Present, ma'am.
14,
13.
14, 18,
Present, ma'am.
20, 24, 33,
34. Present, ma'am.
30,
33
34,
present, ma'am.
34
36,
present, ma'am.
136. Present, ma'am.
35,